Every single group trends down. Pool them together and the line points up. Same exact points. How can the same numbers say two opposite things? Let's rewind and find out. 66 people, their weekly exercise and their cholesterol fit one line and the slope is positive, which is obviously nonsense. So watch what happens when we color the points by age. Within every single age band, the slope is negative. More exercise, less cholesterol, exactly as you'd expect. Age was the hidden third variable. Me! This is not just a textbook curiosity. In 1973, Berkeley admitted 44% of men to grad school, but only 30% of women. It looked like clear bias. But then the statisticians split it by department and the picture changed completely. Department by department, women were admitted at an equal or higher rate in 4 of 6. The catch: women were applying to the more competitive departments. Department, the hidden variable, moved both numbers at once. The pooled average reversed the truth. No libraries. The slope of a best fit line is just covariance over variance. Two sums over the data. Run it on everyone pooled together and we get plus 12. The numbers insist more exercise means more cholesterol. Now the exact same function per age band. Every single one comes back negative. Same data, same math, the opposite answer. And we can catch it automatically. If every group disagrees in sign with the pool trend, the code flags the paradox for us. So that is Simpson's paradox. Fit a slope, pool everyone, split by group, and compare the signs. When they disagree, trust the groups, as long as the grouping is meaningful.